Here we are, folks. This is the third lecture of the first lecture, so part C of lecture 1. So what we're going to do in this lecture is kind of give an overview of the course and then introduce the first topic, which is memory. Okay, so the course itself is, the title is Computer Architecture and Assembly Language Programming. Essentially, computer architecture is just kind of the study of the modules that make up a computer and how they talk with each other. Not a super big deal. You know all these modules already except for memory, and that's today's topic. Also, assembly language programming. It's a low-level programming. Essentially, to be able to do this, you need to understand how the computer is put together, which means you need to understand the low-level hardware on this. So the course itself is a notion of building a computer. So we provide you with the diagram of that computer. You're not going to have to design it from scratch, but you're going to have to implement it. And by all means, you're going to have to understand how those modules work together. And once you get it put together, you're going to be programming it with assembly language. So assembly language, low-level programming language, works really closely with the hardware. This is a unique course in that you have to be able to both program and understand the hardware you're programming on. So the issue in this class is there's experiments that support the building of the computers. So we're going to provide you with a diagram and most of the modules here. You're going to be designing some of the modules. In the course of designing those modules, you're going to be able to understand how the computer is put together and how it works and all those fun things. So computer, what is a computer? It is a device, essentially a hardware device that sequentially executes a stored program. So the issue here is it has a program as you know it, but it's stored somewhere, and it's going to be stored in memory, and we'll be talking about that later today. So this down here, this diagram is the accepted high-level architecture of a computer, and what you want to take from this is there's three main parts. You have a processor, central processing unit, some people call it memory, and I/O. So these are the three main modules of a computer. This is certainly something you want to take away. So memory, certainly that's going to store the program and other data. I/O allows you to talk to it, and the processor essentially it grinds bits, calculates stuff, etc., etc. So this is a little bit, this is what we were looking at in the last slide. This is a little bit more low-level diagram of a computer. So we still have a memory, a processor, and I/O, but what we're more interested in is how these modules work together. So to make a computer useful, the only reason it is useful is because it takes in data and it kicks out data. So it's generally speaking going to take in data, grind it around, give you some type of result, and kick it back out. That's the I/O part. So the memory, generally speaking, as you look at this thing, it has two types of things that it's going to store. One is the instructions, and then there's going to be some generic data as well. So what's going to happen here is the CPU or whatever, the processor is going to grind that data around, pass it back and forth between memory. But also there's a control unit in there. The control unit's controlling the grinding of the data, we'll say, but the control unit is acting under the direction of the instructions. So the instructions are the program you wrote. The program you wrote is essentially going to control the control unit. The control unit's going to control all the underlying hardware to give you the result you want. So you've programmed before, at least hopefully anyway, and you've probably done it at a high level. And so this is your high level programming mode, where you would write some code, and generally speaking, I'm not sure what you wrote, but you'd send it off to the compiler. The compiler would generate an assembly code. The assembly code would be translated to machine code, and your computer would run. But this box here is essentially a piece of software that magically takes the text you wrote, churns it around, and makes your computer run. So that's kind of a real high level definition. Certainly something that a computer scientist would understand, but that's not good enough for us. So what we want, we're going to look at this low level here. A computer is digital hardware device. It only understands ones and zeros. Okay, whatever program you write, somehow, somewhere, it's going to be translated into ones and zeros. Those ones and zeros are what control the underlying hardware. Okay, so essentially those ones and zeros make up what we call the machine code. Certainly you could write machine code, put that into your computer and it would work, but that's not the way we do it. Machine code is just not understandable. It's just a big giant set of ones and zeros. No one can understand it. So for this course, we're at this level here, which is the assembly language level. So we're going to write an assembly language program here. We're going to send it off to a piece of software called the assembler. The assembler is going to generate the machine code, the ones and zeros, and that's going to be what drives our computer. So once again, we're going to write our programs in assembly language. The assembler is going to translate that assembly language to ones and zeros, which is the machine code, and that is going to drive the computer. Yeah, so this is a really fast overview, so don't sweat this out or anything, but what we're interested in are any new computer we look at are the instructions that we get to use, and here's a giant list of instructions. You don't really need to know this except for the fact that there is a giant list, and don't be intimidated by this list. Although it looks like a lot of instructions, a lot of the instructions are very similar. The computer itself, it just really doesn't do that much. And once you get a feel for what it can do, these instructions there's really not that many. Guaranteed. Okay, so what we have here is a big, giant, amazing circuit, but for us as programmers, we don't have access to controlling that giant circuit. We only have access to controlling parts of that circuit, and these are the parts. Okay, so they call this the programming model or the programmer's model, and essentially what this means, and this is really important, I always tell people they need to know this, the instruction set here controls the parts of the computer that essentially controls the resources in the programming model. So these instructions control these resources, and generally speaking, these resources here are registers of some sort. So these are true registers here. These are registers also, and this is memory, which you can think of it as an array of registers, which we'll get into that later. Okay, but more importantly, here's the instruction set of my hardware. The instruction set are used to control the hardware listed in the programming model. So this is a more high-level diagram here. What we have is the instruction set controlling these instructions, controlling this hardware. The reality is this is the computer hardware. This is the full computer hardware. This is the hardware that programmers have access to. So you, in this course, you're going to be programming this stuff, etc., but you're going to be implementing all this big circuit here, and you'll need to understand both. So a programmer, a pure computer science person, generally only understands this much, the programming model. You're going to be able to understand both the programming model and the underlying hardware. Okay, so there are essentially two types of memory out there. I made these definitions up, so don't use them in an interview or anything like that. Essentially, I call it incidental memory and structured memory. So incidental memory is just kind of small memory, such as a flip-flop here and there or a register. But what we're kind of moving towards today is structured memory. Structured memory. So structured memory, it's relatively large compared to what you'll see in registers and flip-flops, and typically it's RAM and ROM. Okay, so structured memory, very simple concept. It's analogous to using arrays in a higher level programming language. Essentially, it's just a set of registers. It's an array of registers where each register has its own particular address. So the address is kind of analogous. Address is a hardware term. It's analogous to using the word index in a higher level programming language.